So I've made you the co-host.
Cool.
Let's get, looks like Monica's in the waiting room. Alrighty, so now we have the option to use breakout rooms.
Awesome, thank you.
Yeah, and the settings, in order to make breakout rooms possible, I had to change the account settings to allow breakout rooms in all meetings. That's the only way to do it. And so if that's something that the Southern California Academy of Science is like, no, we don't want breakout room settings, just let them know and they'll have to disable it.
I will, yeah. I don't know why it wouldn't recognize the CAPTCHA that I was typing in. I was just in this account last night. We had a board of directors meeting for Southern California Academy of Sciences. So what happened?
Hey, Monica.
Hello. How's the new place?
Oh, it's great. Yeah, we're still like living in a pile of boxes, which it'll probably be for a while, but we have our own space. I'm really excited about it.
That's awesome.
Hi, Shelly.
And Shelly, I'm gonna get to spend a whole day with you in the lab in April.
Fantastic. Whose lab?
Oh, sorry, Shelly Moore. I'm coming to visit the Moore Plastic Research Institute on April 8th for the whole day.
Is it April 8th or is it the 14th?
I believe the 8th.
Okay, let me double check the date on that. Yeah, the date we have is April 14th, the Thursday.
Oh, Win got the day wrong. I'll text him. Alrighty, so it's 11, so I'm gonna let everybody in.
Good morning. Welcome, everyone. So we're going to go ahead and get started. Welcome, everyone, to the second quarterly meeting of the Microplastics Monitoring Subcommittee of the Trash Monitoring Subcommittee of the California Water Quality Monitoring Council. I'm happy to introduce our co-chairs, Dr. Monica Arienzo and Shelly Moore from the Moore Plastic Research Institute. As a reminder, the California Water Quality Monitoring Council is a non-regulatory collaborative body that's focused on increasing the efficiency and transparency of water quality and ecosystem health monitoring. The Microplastics Monitoring Subcommittee is meeting quarterly, and the goal of this committee is to build a local and global community exchange of information and data for microplastics monitoring methods and tools. Right now, based on your input, we are focusing on developing a sampling and analysis playbook, developing risk communication strategies for microplastics in drinking water for consumers in California and elsewhere, developing data analysis protocols and harmonized methods, and assisting laboratories in accreditation. This is currently what we're focusing on, but clearly there's a lot more interests and needs of this group, so we can expand this going forward. Building off of the trash monitoring playbook, we are going to be developing a sampling and analysis playbook specifically for microplastics. As many of you are likely aware by now, we have developed standardized methods for drinking water, and we're finalizing methods for ocean water, wastewater, sediment, and fish tissue through a collaboration with the Southern California Coastal Water Research Project using infrared and Raman spectroscopy. Additionally, last year, the National Academies of Science, Engineering, and Medicine released a consensus study report on the US's role in the global ocean plastic waste crisis. And they recommended that the US develop a national network for monitoring, referencing some of the work that's gone on in California from SFEI, as well as Heal the Bay and some other local organizations. And so what we would like to build through this collaborative network is a model for this national network to inform decision-making and policy. We have a couple of local bills in California that require some actions on microplastics from state agencies. Senate Bill 1263, passed in 2018, requires the development of a statewide microplastic strategy. And on February 23rd, the Ocean Protection Council unanimously adopted this strategy. You might have seen this in the news. This is really exciting, and this sets forth our roadmap for going forward to develop risk assessment framework, develop standardized methods, get some baseline occurrence monitoring data, figure out how plastics are getting into our environment, and then going back to the legislature with source reduction strategies by 2026. So this made it into the New York Times this week, as well as some other big publications. So this is really exciting to see a lot of momentum being built around this statewide microplastic strategy. For drinking water, we have a similar mandate. Senate Bill 1422, also passed in 2018, requires that the State Water Board define microplastics, which we did, and by July 1st of 2021, we're required to adopt a standard method, 4 years of testing and analysis, develop a health-based guidance level if appropriate, and accredit laboratories to monitor for microplastics. So we're working on finalizing our plans for drinking water analysis right now, and we hope that this body acts as a means for laboratories to be able to get into the accreditation process and assist water systems in getting involved in this effort. As always, the recordings from these meetings are made publicly available on YouTube. So if you want to go back and view any of the presentations that we've had at previous meetings, or if you miss part of this meeting, feel free to go to the YouTube channel. We'll send out the link after the meeting. And that brings me to today's agenda. So just went through the introductions, and we've got an exciting agenda today. So from now until noon, we're going to be hearing from guest speakers, Ben Maurer and Dan Haught. And then at noon, we're going to transition to introducing our initial work groups and leaders. We've got a consumer messaging work group that's currently led by Brent Alspach, and a sampling and analytical methods playbook work group led by Shelly Walther. After the breakout rooms, we'll all come back and report out from those breakout groups and adjourn the meeting. So one more thing before I pass it over to Ben and Dan. We have been speaking with the project group leads, and they've recommended that we have some different platforms for information and data sharing. I'll leave it up to the individual work groups exactly what they want to use, but I have already set up a Google Drive for us to use. This has unlimited storage space. You can access it through the bit.ly link here. It's just bit.ly/microplastics committee. We also encourage you all to share studies through Zotero, shared folders, code through GitHub. These are just a couple different platforms, and I'm sure you all have more ideas for how to share information. So without further ado, I'm going to hand it over to our first guest speaker, Dr. Ben Maurer over NREL. And Ben, if you'd like to share your slides, I'll make sure that you have sharing abilities.
Sure, thanks, Scott. Let's see if I get this set up painlessly here. So which of the two can you see? The proper one or the improper one?
I see the presenter, the
Presenter view.
presenter view. Yeah,
Thank you, thank you. How about now?
that looks good.
Great. So thanks for the opportunity to present. I'm Ben Maurer. I'm from the National Renewable Energy Lab. We're a DOE-funded, federally funded research and development center, FFRDC. I'll be presenting today on two national labs projects, the Water Pack project that's funded by multiple offices within DOE. So we have funding from the Water Power Technologies Office at DOE, the Advanced Manufacturing Office, and the Bioenergy Technology Office, as well as the Office of Science, Biological and Environmental Research Office. Lots of terminology to say that we have multiple interests funding this project from DOE, and we're partnering with a number of other agencies, including EPA, to move this project forward. We've been working on scoping this project out for the past 18 months or so, and we are just starting to move into the first phase of execution, which I'll be telling you about mostly today. But I want to recognize that this is a joint project between PNNL and NREL. I'm the PI, but there are about 30 some odd folks from across multiple disciplines, researchers at the two labs that are supporting this project and will be supporting the project in the future. And I think one of the first things that comes up as we present this is why DOE? It seems kind of an odd space potentially for the Department of Energy to play in, but there are three main reasons why energy wants to play, the department wants to play in this space. The first is that above all, DOE is among the chief technologists within the federal agency space and are entrusted with fostering industry. Energy is a big part of industry, but we also work in a number of other areas peripheral to energy, and this is one. The second is that renewable energy, which is where most of this funding is coming from, the Office of Energy Efficiency and Renewable Energy, generates a fair amount of plastic waste between wind turbine blades, solar panel cells, and the like. There is an issue with a circular economy developing around renewable energy technologies and making sure that that is as tight and as closed as possible. So this falls under that thrust as well. And then finally, the third reason that DOE is interested in this is if we're going to be developing technology solutions, which is what DOE is good at, it would be great to have those solutions be A, renewably powered, and B, somewhat related, not necessarily tied to shore power. So we could deploy these sensing and collection conversion solutions separate from wherever there's a plug on the shore. So moving on to the broader vision here, we took a long stance on this, recognizing that this is an issue that's gaining a lot of steam and that we're interested in participating in, but not necessarily starting from a position of a lot of experience or information. We took the long view here. And relative to 2016 numbers, we're looking for a 50% reduction in plastic emissions through 2040. And that's cumulatively, and it's all sizes of plastic, not just microplastics. And by some very conservative estimates, chances are that this may be even an order of magnitude larger than this. We think that there's 10 million metric tons of plastics that we could recover and reintroduce into the circular economy, which is a main focus of DOE's. So I mentioned that there's a technology interest that we have here. 3+ years from now, we'd like to be actively advancing a portfolio of technologies, leveraging work that's already being done at the national labs in terms of sensing, collection, conversion, and redesign. I want to mention at this point the Bottle Consortium, the biooptimized technologies to keep thermoplastics out of landfills in the environment. It's a mouthful, but they're doing really great work, mostly on terrestrial, but they do some aquatic and marine plastics as well. Looking at reclamation and circular economy pathways for polymers. So their website is bottle.org. They're run out of NREL where I work, and it's worth a look if you're not familiar yet. We'll be working with them on conversion and redesign primarily. They already have quite a bit that we'll talk about over the course of the talk today that we'd be leveraging. But there's also existing technologies in sensing and collection that are worth mentioning that we'd like to build on. So for example, in sensing, Pacific Northwest National Labs already has a centimeter nominal length sensor package, a lab on a chip that's waterproof that they've been using as fish tags to characterize movement of fish around hydropower installations. These would be a really great tool, for example, for extended producer responsibility, throwing these into a river, understanding where they distribute downstream, validating fate and transport models with technology that literally is off the shelf already for the labs and could be pivoted and co-opted for this sort of an application. There's a number of remote sensing, in situ sensing, benchtop sensing technologies that we've developed as labs that could be used for this problem. Currently, they're being used for things like phytoplankton, zooplankton, harmful algal blooms, trace contaminants monitoring in watersheds, et cetera, that again could be co-opted for microplastics. On the collection side, we do have at the labs, we have a pretty aggressive portfolio of marine devices you wouldn't imagine for renewable energy technologies, but river and ocean technologies that harvest power from currents and from waves. For example, there's a lot of transferable technology and a lot of transferable development and testing tools that we have that could be pivoted again to work on developing technology specifically for harvesting microplastics or macroplastics. I won't go too much into conversion and redesign since that's more Bottle's domain, but we are going to be working really closely with them to address US river plastics specific questions. So these would be things like, how do you take a slurry of degraded, fouled, heterogeneous plastics and use that as a feedstock to develop monomers and polymers downstream in your supply chain. And then finally, redesign. We're interested in how to keep plastics initially out of the water and also how to redesign products, processes to reincorporate plastics that have been recovered from waterways back into the supply chain. So as I mentioned before, for those last two, there's quite a bit of work ongoing, mostly for terrestrial systems, but we're leveraging what's already being done and trying to pivot that towards waterborne systems. So when we first set out on this a few months back, we thought we would be able to go to the literature and have enough predictive power from the models and the measurements that had been developed so far to be able to start directly on a technology development push and have that portfolio just build on the existing data and the existing literature. And what we found was there are a ton of really great studies out there. Unfortunately, a lot of them weren't comparable or reproducible on a national scale. That was a real challenge when we tried to look at how to tune a Raman spectroscopy in situ unit, for example, or how to figure out collections of floating versus suspended versus sinking plastics. There just wasn't enough information to cite things and try to develop things at a national scale. So the plot on the right is a model that was developed by, I believe, Breton. And we tried to extend that model into a specific site and match them against Ocean Conservancy data that they generously provided to see what sort of predictive power we could have for what plastics to anticipate in that location. And what we found was there just wasn't enough information. So this is really the graphical representation of what I was mentioning ago. And it really highlighted a need in our eyes to go do not necessarily a rehashing or a restart of what had been done, but ideally a benchmark study to tie what had been done together and provide that basis, that full spectrum basis of color, size, shape, chemistry, additives, position in the river data that we would want to begin to develop those technology solutions. So trying to slot something into the existing literature so that we could start to move on technology development solutions. What we decided to do after reviewing what had been done and where the opportunity areas were and what our technology development needs were, was to focus on 5 rivers in the US. These aren't the top 5 most polluted rivers, although they include some of them. They're all very polluted, very different rivers that we thought represented multiple views of the broader US spectrum of conditions, whether that be magnitude or weather or nearby population, anthropogenic influences, existing infrastructure, opportunities for deployment or planned deployment, variability in the flow, but also in the substrate, whether it was built out or sand or whatever. So this is a quick slice of some of the rationale we use to come up with this. And you'll notice at the top, there's energy. We are still focused on finding renewable energy solutions to those 4 pillars for sensing, collection, conversion, and redesign. So seeing what solar energy was there, what wind energy was there, and most importantly, what water energy was there to power these solutions was top of line. We also obviously wanted to know what percentage of the plastics we were gathering between these 5 rivers. According to some of the early models, this is at least half, if not 2/3 of the plastic represented in our cross section here, and then about 1/4 of the US population as well. And I'll draw your eyes down to the bottom of the table here. Scott and Monica asked me to emphasize how we're partnering with folks to get this done. I want to go back to the earlier statement I made that we are very new to this space and we are somewhat inexperienced. We have amazing polymer characterization capabilities through the labs already, but we haven't been working in waterborne plastics. And so from the get-go, we were really focused on partnering with folks who have been, and we've been very, very lucky to have had great support from EPA, Environmental Protection Agency. They are going to be working with us in the Mississippi and the Delaware rivers specifically, leveraging ongoing work that they already have established and pivoting a little bit to meet our requirements. For the Sacramento, Los Angeles, and Columbia, we're currently contracting with partners trying to leverage existing expertise, existing equipment, existing personnel experience so that we can address collection, sampling in those rivers. And we're hoping to have that all buttoned down by Q4 of the fiscal year here, when our field season would start, but that's currently underway. I'm not going to mention the specific partners we've talked to until that's fully contracted. An opportunity today, though, I would say, is we're looking to expand out the work that we're doing beyond just polymer characterization and river characterization to include community and individual characterization around those rivers to understand what the impact of these plastics are on communities and on individuals and ecosystems. We have some of the foundational data methodologies, sampling methodologies planned out to get that background physical and polymer data, but we're actively looking for partners who have existing ties to these communities around these rivers and who could help us quantify and understand the dependencies and relationships between that pollution and its effect on the ecosystem, the communities, and those individuals. And I'll return to that later, but this is still an open question. We're still actively seeking partners in all 5 of these spaces. The approach for us is to look at these look at sampling these rivers downstream of a major urban center and upstream of a river mouth to the ocean, specifically trying to capture fluxes of suspended plastic as they move seaward. So this is not the sediment. This is not necessarily the riverbanks, although for flooding events, we'll probably try to sample on the riverbanks. And this is just a single cross river bank to bank transect that we would be repeating at a seasonal high, a seasonal low, and at least one flooding event. So it is geographically constrained, but that's the trade-off that we're making to be able to take a really fine, broad spectrum look at these three categories of variables within the river along that transect. So we're looking within the river, sorry for the eye chart, but on the river category, we're looking broadly at the physical forcing that the plastics experience as they travel downstream, trying to better inform fate and transport models. And we're also looking at the available renewable energy that's there. So what current is there? How could it be leveraged? Is it of a character that we could actually place a turbine, for example, to power something, or a water wheel? Under the plastics, this is probably our most ambitious push, and we're trying to do all of the things here. So this is the broadest spectrum of size, shape, chemistry, additives, level of degradation, and position cross river that we can take. And I'll go into a little bit more detail on what that workflow, what that sample flow looks like. I will warn you that I'm not a chemist. I'm an environmental scientist and a fluid dynamicist. So I can direct you to the people who know, but I'm not necessarily going to answer chemistry questions. We are setting this up, though. We have won competitive awards in addition to the DOE funding that we've received through the labs. And we have a pretty broad look at this thing, all the way from large scale macroplastics down to leachates. And then finally, there's the locality. I mentioned this connection to community as we search for partners, and it's the infrastructure that's there, it's the competing uses, it's the opportunity to cite existing infrastructure, to cite solutions, and it's trying to map causally the presence of plastics and their effect on environment, community, individuals. The workflow, excuse me, for us starts at the rivers. We're anticipating 5 rivers, 3 times sampling in each river over the course of a 12-month period. We think that's going to generate between 150 to 300 bottle samples. This is separate from the net tows that we'll do, but bottle samples between 4 and 10 liters each. They'll be brought to NREL's facility in Colorado, where they will be spun down and filtered, separated at this is still being decided, but at a minimum size of, or minimum weight of 500 to 600, I think it's 600 to 700 actually, 600 to 700 Daltons. The solids larger than that will stay at NREL, where they'll be characterized both with microscopy and then destructive methods. The leachates and the rest of the aqueous retentate is actually going to be sent to a separate lab. It'll be shipped to PNNL in Washington State, where they'll be looking specifically at additives, degradation products, vectored chemicals, with a hit list of compounds that we know are toxic, and then a broader exploratory list of compounds that we are thinking to look for, but don't know whether or not they're there. There's not the backing in the literature. And if folks have input there, we've already talked to a few folks on this call, I think, but if there's additional input there, we're very open to how to do that. The field sampling and laboratory analysis is going to feed fate and transport efforts in this first 2-year push, 1.5-year push. We're going to ride on the back of a very ambitious modeling effort in the Delaware River, Delaware Bay, other side of the country from California, but we'll be looking at adding a plastics module that sits atop their vegetative slope to coastal sea complete numerical model that's going to include everything from physical forcing to anthropogenic sources. So we're building out just a little bit of capability on what's already a very ambitious Office of Science project. If you'd like, there's a website at the bottom there. The ICON project is definitely worth a look, and very lucky to have this already underway that we can piggyback onto. We're going to tie the the modeling efforts, the field measurements, and any other data that we can acquire from the community that we can use with our benchmark data set, and try to assign rigorous monetary value to these things. So the labs, plural, have been doing this for a good while, and we have existing tools for life cycle analysis, environmentally extended input-output models, material flow through industry models that we're going to be feeding with the data for what plastics are there, what mass, size, shape, level of degradation on the reclaimed plastic feedstock value side, the left side there, the GHG, the energy invested and the dollars invested side, to see if when you reclaim these plastics out of the waterway, what they're actually worth in the supply chain again. On the other side of this, and a much fuzzier, but we're actually making some early traction, which I'm really excited about. We're trying to quantify effects on communities, evaluate effects on communities, on individuals' health, and on the environment, leveraging what's been done already and trying to take a more integrative and perhaps in-depth look at those costs of remediating pollution or leaving it in place. So overall, we'd like to have a single currency, recognizing how dangerous that is to oversimplify things, but we'd like to have a single benchmark for dollar value of these things that we can share and talk about. All of this will be hosted on a centralized website. We recognize there are a number of websites already in existence, but looking to have one that specifically focuses on this technology solution data set. And it, in addition to that, links out and leverages the other websites and the other ongoing work that's happening. We've already started profiling the 105 SMEs that are small, medium enterprises that work in this space, our agency partners and folks, to understand their needs, and trying to develop this website specifically to advanced solutions, advanced technologies from the partners already working in the space, as well as DOE. And we're anticipating the beginnings of this will be available at the end of this calendar year. The timeline for all of this, right now we're gearing up for our basically kickoff workshop with our partners who'll be working in the rivers, trying to homologate our sites, methods, equipment, and data approaches. We're working with the Maurer Institute and Win Cowger there to try to make sure that this is as reproducible broadly and as integratable into existing literature as possible, and that it's also very doable by our partners and can feed our technology development needs. We're hoping to begin fieldwork middle of this year, middle of summer, catching the rain year, and carry on through a 12-month period where we, again, for those 5 rivers, capture the seasonal high, the seasonal low, and 1 flooding event per river. All the downstream tasks, modeling, valuation, will start after our first field campaign, and we're already actively working on building up the website. We have the first mock-ups and architecture in place. We're hoping by the end of this to have an estimate of the US ocean emissions flux at those 5 rivers that's expandable out by future work, and that can maybe leverage other work that's already in existence to model a little bit more effectively than the good work that's already being done. And then, as I mentioned before, have some valuation estimates to motivate technology development, which would be phase 2 of this project. So looking at this in a quick comprehensive view, this is a graphic that we developed for this. So we're looking for renewable power to develop sensing, collection, conversion, redesign. We're centering this around evaluation push and looking at the broad spectrum of plastics, hoping to feed a circular economy and also healthier communities, healthier individuals, healthier ecosystems in the US. So with that, thank you so much for your attention, and super happy to answer questions. There's a lot I skipped over, and there's a lot that's still in process, trying to be understood and decided upon. But yeah, really grateful to be here and really interested to hear what folks have to say.
Thank you, Ben. That was a fantastic presentation, really interesting. So we've got a few minutes for questions. People want to just go ahead and unmute and ask, or you can also enter your question in the chat. Go ahead.
Looks like there's already some questions in the chat.
Yeah, sure. Should I just take a stab at things?
Sure.
Great. All right. Can we do better than 50% reduction of Yes, I love this question. So this is, yes, this project is geared to do well better than 50%, but we've set 50% as what I think is an attainable bar. And I have now had to justify this 3 separate ways by 3 different ways of calculating this to DOE in ways that they're comfortable. And all 3 of them are complementary, but we set that as a minimum bar, and it's also based off of some models that have been revised. So I think we can do well better than that. I don't have a number for how much better, which would be the next question, but I'm confident that we can hit that, and that's what we're pushing for, better than 50%. So thank you for that question. Yeah, Erica, so your question on given the unpredictability of precipitation events in California and everywhere really, how will you ID seasonal highs and lows? So that's a great question. We're working with local partners, and that's going to be one of the questions in our workshop that's upcoming. The straw man that we're putting out to our partners to start that discussion is there are historical averages, right? And I recognize there's ENSO events, there's drought cycles, there's all sorts of other mitigating factors that make taking a mean really difficult. But we're starting with the seasonal mean, or excuse me, an annual mean, and we might move to an ENSO mean or a decadal mean or something like that. But we're going to go in the highest flow, the lowest flow months historically with whatever mean that we take, and really defer to the expertise of the local partners and make sure with this workshop and ongoing discussion that everyone is at least taking the same approach to identifying those and going out on days. And unfortunately, there are a number of limitations to our approach, right? This is a single year. We'd love to repeat this later, but it'll probably be a few years before we can repeat it. We're only going out 3 times. We're not doing this continuously as much as I would love to have the funding to do that. There's a bunch of big opportunity areas to improve our approach. But I think for our purposes right now, we're trying to make this very reproducible, very doable in future years as well, and at least homologated across all of our partners so that this is a standard approach and a benchmark data set. But you're totally right. I think the bigger one that I'm worried about is the flooding events. Being able to scramble people fast enough and get out there and not burn the funding and the time and the resources and then have a bigger event come just after. Or other side of that, in the Mississippi, if it's a hurricane, how we ensure safety and operate in those sorts of environments. Give you a second to come on if there was something that you wanted to add or ask for either of those questions.
That's great. Thank you.
Thanks. I am also very aware I owe you an email, by the way. Brent asked, is DOE interested also in airborne microplastics? This came up a little bit in internal discussions a while ago, and I certainly can't speak for DOE. I can't even speak for NREL. I can speak for our project at NREL. But I can tell you that in our conversations with DOE, they were very interested, and I'm not sure there was a place to put that bookmark or that interest, but folks at the political level and above had been very interested in understanding a recent paper that came out that said that suspended microplastics change the albedo of the Earth, and that we've been touting a statistic internally to get people motivated about the precipitation of microplastics into untouched lands and inaccessible lands in the US. So I would say there's interest there. I haven't seen, and I don't know all the projects. There could very well be one in the Office of Science side of the house that does this, and I would be unaware, as opposed to where I live within ERE, energy efficiency and renewable energy. But that said, I'm not aware of a project that looks specifically at airborne microplastics. But that's not to say that these sorts of efforts between bottle and water pack couldn't grow in that direction either. Any plans for data collection in LA River after 2022? Is this a one-time snapshot? That is a great question, and I alluded to that a second ago, but we have in our multi-year project plan that we would return to these rivers after the first RD&D push, once we've had a chance to deploy or once our partners have had a chance to deploy their technologies that we'd be advising on, to benchmark progress and see if what they deploy is making an appreciable difference and validate those technologies. That is so funding dependent. We would love to do that. It's in our plan. We've talked to DOE about it, and we're not sure if we would get that funding 5 to 10 years out. But I would love to come back. That's something that's come up with a few times. I'm curious if a lot of plastic equipment is used for the sampling. Oh, yeah, I just learned from one of our partners that HDPE bottles have a problem with static electricity and microplastics. So there is an effort right now. I didn't mention this and I should have. We just had our first preliminary pilot samples sent by the Delaware Region 3 EPA group. Kelly Summers there has been awesome to work with, and she went out and collected some for us in HDPE. And we shipped them through and we're running through our processes. We've actively been developing, well, I don't want to oversell that. We've been working hard on an SOP based off of what's already in existence and working with Win over the last couple of weeks only. But for about a year, we've been looking into what SOPs exist and how to integrate those and get something that works for our purposes. We're very aware of the contamination issue. We already have that concern for some of the other labs and the projects that they're working on. And we're running the first pilot samples through right now to understand how much that's an issue. And we have standards and blanks right now that we're running through for that purpose.
So
Scott, I want to check in on time.
Oh yeah, checking. I was just about to say we should probably move on to the next speaker, Dan. So Ben, if you want to just answer those questions in the chat, that'd be great.
Will do. Thanks, everybody.
So Dan, whenever you're ready, get started. There we go. All righty. Looks good.
Can you guys hear me? Can I get a sound check?
Sounds great.
You can see my full screen too.
Everything looks
Yes.
good.
Perfect. Thank you. Well, thank you everybody for thank you for the invitation, and thank you everybody for spending some time today talking about such an exciting topic. Today I just kind of want to introduce myself and some of my colleagues at the USGS, the ideas that we have and how we see ourselves fitting into this problem of microplastic transport. I want to take an opportunity to discuss some of my ideas and some of the direction that our group is moving towards. And some of the key questions that we have identified thus far. So I worked for the USGS back in 2012 with Dave Schulhammer and Scott Wright, where we worked predominantly on sediment transport projects, and that's kind of where my background exists. I did my PhD at Simon Fraser University, where I studied sediment transport in the fluvial environment predominantly. I used multi-frequency acoustics as a surrogate for suspended sediment to look at particle size and concentration of sediment as it moves through the system to compute sediment fluxes. So it's from this perspective that I have that we can kind of relate to microplastics in the context of transport or particulate transport. And I think one of Scott's colleagues in the past had mentioned in one of the first microplastics community webinars that, you know, we expect microplastics to transport very similar to fine particles. So it's not a new concept by any means, but it's a very interesting one that fits well within the realm of the USGS. Some of my other work is related to flocculated particle transport and bed form dynamics. Not that these really have, like, the flocculated particle transport I'll speak more towards later, but we kind of want to, I kind of want to share myself with you guys to kind of give an idea of where my perspective comes from. The group that I work with and colleagues out of the USGS California Water Science Center, led by Dr. Paul Work, study sediment transport through the bay. And you can see the figure on the left here shows a lot of the sites that we monitor throughout the bay. In addition, we also have a team that works up more in the San Francisco Delta, so the upper end of the estuary itself. And we've done a lot of work in this area monitoring predominantly suspended sediment, utilizing turbidity as a surrogate for sediment. And I'll kind of speak more towards this idea here in a little bit, but I just kind of want to introduce my colleagues that I work with. Another thing I just wanted to kind of bring about is how I became interested in microplastics. As a PhD student, I was kind of asked to examine some filters that we had collected on the Fraser River based on sediment to kind of look for microplastics in the filters. It's a very meticulous and labor-intensive endeavor, and it didn't really become too fruitful, as many of you guys could probably imagine. It's when you don't plan to look at something, to look at it after the fact, it's quite difficult. But it did get me interested in microplastic transport and engaged me in this idea that has become more fruitful now that I'm back at the USGS. I have also become more interested in kind of macroplastic transport, as I live here in Carmichael, a suburb of Sacramento, and I live on a small creek where we see a lot of transport kind of coming through our creek during the wet season, the limited wet season that we have here. And you see it firsthand, and it has brought my attention to this this problem that we have, and really how we see plastics degrade and move through the system as a whole. And so this is kind of just a sub idea that I have related more to macroplastics, and I just kind of want to give everybody an idea of the perspective that I have, where we see, plastics being entered into the system, through these small tributaries that eventually lead down here into the American River on the left panel. And it kind of brought forth an idea of how to kind of understand these transport parameters at the very basic scale of being able to image these things continuously and understand, our basic concept of flux, which, is flow times concentration generally. In this case, concentration by number. But I do want to kind of stay on the topic of microplastics, so I'll move on. So when I think about microplastics and kind of my idea of how it moves through the system, I'm predominantly kind of focused on the freight transport aspect of it. And obviously it's a much larger problem, as we all know. But how the USGS is focused and how we monitor and our monitoring programs are set up is very much suitable for the fate of the particle once it enters these larger systems, such as the Sacramento, San Joaquin, and the American Rivers. So we have these monitoring systems already in place for a lot of other water quality parameters. So my initial kind of questions that I have developed kind of thinking through these microplastic problems is, how can we kind of accurately sample these microplastics in situ to quantify the size, concentration, and flux? How can we quantify the key transport parameters to determine the fate of microplastics once they are in the system? And how does that differ, or is it similar to fine sediment transport? And I'll speak kind of more on this here in a minute, but it's a very critical question to kind of understand how similar and different microplastics transport once they've entered the system, because it speaks a lot towards how and where they will end up. And then the last question that I've kind of started with in my direction is, do microplastics transport similar to a singular particle, like a sand, for example, or do they actually change form and aggregate or flocculate like we see in fine particles? I haven't seen much work on this in the literature, not that I've done a completely exhaustive examination, but it is an interesting question, because flocculation of particles changes the settling rate, and that changes the fate and how it moves through the system. And I'll speak a little bit more towards this too. So one of the key ideas I kind of have, or my approach to these questions, is to kind of treat fine sediment as a surrogate of microplastics as it moves through the system. And we can kind of do this because they should transport similarly in the system. And obviously we need to do more research in actually the mechanics of microplastic transport, but it should move through the system similar to fine sediment, where suspension, and so the suspension number is kind of a Rousean concept, but the suspension of any particle is kind of driven by the upward shear stress, U star here, versus the settling velocity of any given particle, and that kind of determines how it moves through the water column, or whether it settles out into the bed. So understanding these key properties to microplastics, which determine the settling velocity, is a critical aspect of this idea. But if you put these together, if we have a better understanding of how these microplastics transport, then we can couple those with hydrodynamic models and particle tracking models to understand where the fate of these microplastics would move to, and whether they and where their sinks are in the system. So this is kind of the idea that I'm working towards developing, and I'll continue on. Suspended sediment dynamics in the San Francisco Bay has been studied for a very long time, and I just chose one of the articles here by McKee and others that have shown that the predominance of suspended sediment or fine sediment, even though historically it came out of the Central Valley during the mining eras, has become more evident that a lot of the smaller tributaries in the bay, South and North Bay, contribute quite a bit of sediment to the system. And I guess the question really exists: where's the source of these microplastics, and how do they come in, and how different is that from the sediment? And is that a critical aspect of this idea of using fine sediment as a surrogate? We can kind of see from these images from this, so I'm sure you guys are familiar with this Rebecca Sutton's paper that kind of showed some of these initial findings of where these higher concentrations or counts of microplastics exist in the San Francisco Bay. But we generally see a lack of spatial diversity in the sampling thus far, whereas if we look at the urban development and the intensity of that development around the bay itself, we see very clear kind of epicenters being in the South Bay, obviously it's the Sacramento area, and partially here in the areas that contribute more to the San Joaquin. So we have predominantly 3 different epicenters of where these sources could come through, under the assumption that the delivery of microplastics comes through these higher urbanized areas. So this presents a larger challenge in this idea of how we can actually quantify and track particles as they move through the system, if the sources are different than the sediment themselves. So it creates a challenging aspect of this work. So one idea, or the critical aspect of this idea, and it kind of actually, Ben had a very good image on that Delaware model where they had a particle tracking kind of model going on there. And how these hydrodynamics models work are that you have to be able to calibrate them. So utilizing flow dynamics in the San Francisco Bay is critical to this idea, but currently there is really a lack of flow gauging in the bay to calibrate these models, these hydrodynamic models. So one thing that our group at the USGS is kind of trying to work towards is developing a more dynamic validation and calibration technique by instrumenting these sites that you see here on the left with ADCPs to measure flow, which then allows you to calibrate these hydrodynamic models and better refine the flow characteristics throughout the bay. In addition, when you use these multi-frequency ADCPs, which is shown here on the top right, you can get particle concentration and particle size from multi-frequency acoustics. That's what my PhD was on, and they've actually developed them better since then, since my work, of course. Naturally, that always occurs, where we can utilize this now that we would have a flux of fine particles and through any given spot, and then you could expand that idea by having a hydrodynamic model, which then shows you where these particles should transport to and where the settling may be preferential and where we would find sinks in the system. So one of the key questions is, how different do microplastics respond, or how different are microplastic, the settling parameters, the key physical parameters of microplastics, how do they differ from fine sediment? And while there isn't a lot of work out there, I've come across several, and I show a couple here on the right. Most have found that the microplastics exist throughout the water column, near the surface, and in the bed material, which creates a very dynamic environment for sampling and tracking. This paper by DeFontaine and others found that microplastics, were distributed throughout the whole water column, and it's quite dependent on the particle shape, size, along with, of course, the local hydrodynamics. Additionally, they kind of suggested that the buoyancy determined whether the microplastic was wash load or whether it deposited in the estuary that they examined, which was the Adjourn estuary in France. So understanding, it kind of comes back to how understanding the particle size settling rate is very critical to our understanding the fate and transport of microplastics. The other question, part of some of the work that I've done in the past with flocculated sediment is whether these microplastics flocculate and flocculate with fine sediment. And a key part of flocculation is that when particles flocculate, for example, a fine particle, when they aggregate together, they increase the settling velocity relative to that individual particle. And if we think about that in the context of microplastics, whether it's fibers or filaments or other, other size particles, that would change the settling rate, thus decrease the entrainment length of that particle and increase the interaction with the bed. And these are all critical aspects to fate and transport of anything, whether it's contaminants, sediment, or other particulates like microplastics. So one of the proposals that we put forth, the USGS, that we're kind of working towards is developing a way to quantify settling velocity of microplastics. And this is kind of following up on some of the work that I have done in the past, where we developed a flocculation camera that tracks flocculated particles that we collect in situ. We collect in situ samples and then track the flocculated particle as it settles. Now, this methodology would work very well for microplastics as well, where we could not only get a settling rate, we could get a shape and a size, and potentially identify the particle itself. So here, I just want to kind of show what we have done in the past, where we created a water column here, and you introduce a sample, physical sample, that then tracks the particles on the left here through time as they settle down through the water column, which then gives you an idea of the shape, size, and the density of the particle. And from the density, then we get settling rate. We calculate settling rate directly when we get density, excuse me. One issue we found with the flocculation camera is that as particles move in and out of the resolution or the focal length of the camera, you can actually lose the particle. And while this was problematic for the flat cam, the development of new technology and imagery and imaging has created the ability to image in a 3D with respect to depth. So developing a new camera that can capture that third dimension would be critical to being able to successfully capture microplastics, as I said, through the water column. Another aspect of this to kind of identify the microplastics just initially would be to kind of utilize Nile red to stain these microplastics to kind of better show up in the camera itself. This would provide us a clear picture of the microplastic particle, but it does kind of inhibit the identification of each individual particle. But it's kind of a starting place for where we see the testing part of this camera that we would like to move towards. The other aspect that was kind of brought up earlier in the question to Ben was kind of sampling, and whether, you know, sampling with plastic inherently has the potential to contaminate the sample itself. And historically, when we do it for sediment, we've used a lot of Van Dorn type samplers that are predominantly plastic and rubber. So it is a critical part of this work to find samplers that cannot inherently contaminate the sample before they go into analysis. So the development of something that can accurately quantify microplastics is critical. And one of the things that we have done in the past is modifying some metal-based samplers that you see here that are capable of pumping the water through them into, if you see the center figure here, a jug. But again, that's plastic. So trying to find a way to quantify the plastic concentration without introducing more plastics is a current topic that we're kind of going through at the USGS and kind of thinking about critically. And there are some current methods that are used for sediment. If you see here on the left panel, there's a list that this instrument actually determines velocity at the nozzle here, and then pumps the water sample through and out. And inside of it, it calculates particle size distribution. Now, while this one it might be useful for microplastics, it would not detect microplastics themselves, but utilizing this kind of idea where if we could pump water through the actual instrument at a known rate, then you could get your flux component while also maybe capturing the plastic particles inside via, let's say, a filter that is non-plastic or non-fibrous. Some sort of metal filter is kind of an initial idea that we have to kind of develop something that will work for specifically for microplastics. And that was all I kind of had today. I kind of wanted to open up this forum and get thoughts and questions and better develop these ideas. But I just wanted to kind of thank everybody for this opportunity to kind of share some of these initial direction that we have. One thing that is a little bit different about the USGS, California Water Science Center, and all water science centers is that we are soft funded. Therefore, we do rely on collaborator funding, which makes it a little bit more challenging than some other federal agencies. So these ideas to work and come together, it very much requires that we have external funding for the most part. And while there are some internal USGS funding opportunities, we generally have to identify external ones. And that's kind of why I wanted to bring these ideas today together to see if we can't find a collaborative effort to continue this work and further develop our monitoring program here in the San Francisco estuary. And that's all I have.
Thank you, Dan. We are running a little bit behind schedule, so we can entertain just one or two questions, and then we'll go to our breakout groups. So if anyone wants to unmute and ask, feel free. You can also write a question in the chat. And if we don't have any immediate questions, folks can follow up with Dan. Oh, so we've got one from Ezra in the chat. Hi, Dan. SFEI is in collaboration with UC Davis and has done some modeling of microplastics movement through the bay. Would it be possible to leverage that modeling so you aren't starting as much from scratch?
Yeah, I mean, I think particularly on the modeling side of things, that's something that we don't do a lot of, particularly at these larger scales. So that would absolutely be a useful thing. It's something that I'm not very familiar with, the modeling at that scale. So I'd be very interested in talking more to people that have experience in that realm.
I'm wondering if you're also aware of the full multi, which is an open source model for microplastics transport through ecosystems. It was recently published out of Europe. Really cool, totally open source. It has a GUI component too, so you don't even need to understand the code behind it.
Yeah, I was not familiar with that, but thank you for that. I mean, that is a part of modeling isn't my aspect, and my hope was here to kind of bring forward a collaboration and idea sharing for that, particularly because it obviously is a key component of this idea.
So we're going to transition to the next part of our agenda. Thank you again, Dan. And if anyone wants to connect with Dan, please reach out through the chat. Dan, if you want to just follow up with people after, that'd be great. And so we're going to transition to introducing our initial work group leaders for the two initial work groups that we have for consumer messaging and the sampling and analytical methods playbook. After we introduce these leaders, then we'll split everyone up into two breakout groups where you can kick off these work groups. So you can choose one of the two work groups to join for this meeting, knowing that you can still participate in the other group after this meeting. So I'm going to hand it over to Brent Alspach, who's leading the consumer messaging work group, just to give us a little intro about what that work group is. So Brent, if you want to take it away. Let me make sure that you have permission to share. So you are now a co-host.
Okay, can you hear me now?
Sounds good.
Okay, I'll reserve the slides until we go into the breakout session, but by way of introduction, it just seems like one thing that the group should do, and I'll try to spend most of the time on in the breakout session, is to understand, for the purposes of consumer messaging, what's the need in terms of who's the audience for the messaging, who is it for, and then who is the messaging to, and then by extension, what goals do we want that messaging to accomplish relative to microplastics. And I'll spend a little bit of time briefing folks on the Water Research Foundation project that we have going on that's along these lines for drinking water, just to ensure that there's no overlap. And then I'll really take it to the group to try to coalesce around those ideas about the audience and the objectives.
Thanks, Brent. And then I'll hand it over to Shelly Walther, introduce her work group.
Hi, everyone. Yeah, so we're going to be working on the microplastics monitoring playbook. That'll include, you name it. And we put a survey in the chat. And so we're going to be looking for your feedback, but we're targeting a year to what we can complete. And if you miss out on the breakout session today, don't worry about it. Go to the one that most fits what you want to be able to learn about and discuss today. We'll share the slides with all of you from each of the breakouts, and but the survey will really help us get an idea of where interests lie and what you deem most important. The playbook itself is going to be a living document, but we want to focus on the first year, what we can accomplish, whether that's an overall guidebook for how to conduct a survey, or what we know about certain matrices or methods, or coalescing that into a useful guidebook for many purposes for microplastics monitoring.
Alrighty, so I'm going to open up these 2 breakout rooms. Again, feel free to hop into the room that you are most interested in for this meeting, knowing that for further work groups, you can still join both work groups, one or the other, whatever you choose. And so I'm just going to open up these rooms and then you can self-assign. Shelly, which room did you want to join? Oh, you're on mute.
Yes, I'm going to go into the playbook room.
Cool. I'll go into the consumer messaging room.
Okay.
And anyone that hasn't joined a room, do you have any questions?
Yes, how do I join?
So there should be a button at the bottom that says breakout rooms.
I see that, and every time I push it, I get consumer messaging. I want the other one.
So should be able to click the other one, the microplastics playbook.
Oh, down, yeah, scroll down. I got it. Thank you.
Yeah.
On that, just in the interest of just making sure we've got time to cover the most important things we'd like to do today. So with that in mind, here's the list of things that I guess big picture need to be accomplished. One is a work group co-lead, which would be terrific. And if someone's interested in serving in that role, please do let me know. Certainly you don't have to speak up on this call. I know that maybe people might want to think about that, but I'd certainly be interested in someone to collaborate with and share the load a bit. So if you want to email me after the fact or reach out to Monica or Scott or Shelly, that would be great, and express your interest. We'll go for it that way. As I mentioned in the big work group, audience and goals are important, as well as what this group may ultimately want to generate for a work product. And then other questions include what platform should we use to host that product? How we disseminate the information out there is also important to make sure that we serve the community that we are targeting. How that all gets done, the timing and schedule, a little bit about logistics, and then for the purposes of next time when we would convene again. What I'd like to accomplish today are those that are highlighted here for the most part. Again, deferring the co-lead to on the side, but audience and goals, the timing, what we're going to do with logistics a little bit. We've already talked about the Google Drive that Monica mentioned, and then the next meeting. And I see these as really the two most important things we'll need to discuss. So as I referenced before, first is the audience. So in the grand scheme of consumer messaging for microplastics, and the bigger purview of the umbrella group in which our work group sits, who is the audience for the messaging materials that we think is important? So who are we generating the materials for that would then use them? And then to whom are those materials directed to help facilitate that communication? And then what are the goals of that communication? And there are a lot of ways that we could affect goals. Is it to educate a certain sector of consumers about microplastics and what aspects of microplastics we think may be important? To convince consumers about something we think is important, either they should be concerned, they shouldn't be concerned, whatever that case may be, or potentially to assuage concerns if they're expressed by consumers about microplastics in the environment, in drinking water supplies, in the air, or whatever we think that may be of most acute interest that we should address with the energy and resources that we have within this group. So I will spend a little bit of time after I go through a few more slides on these subjects to identify the need, and I'll really be looking for feedback from this group about what that is. I did want to give people the background on the Water Research Foundation project that we're currently engaging in, just so there's an understanding of what's already being done, such that we don't overlap with that effort and potentially complement it if we think that's the most important task that we want to take up. So with that, I'm going to just go through some of the slides we shared for a kickoff meeting for this project, which is WRF 5155, titled Developing Strategic Consumer Messaging for Microplastics in Drinking Water Supplies. And the team is Arcadis with myself as the PI, and then Katz and Associates. Some of you may know Patsy Tennyson and her firm, one of the leading consumer interface firms in our space in drinking water, and then FM3, which is an opinion research survey, and Dave Metz is the principal for that firm on the team. I mentioned a couple of support staff. I've got Serena and Alma, both I think who were on this call today. So just to let you know, they're helping me with this project, and I hope will participate in this exercise as well to the extent that it's complementary. And then I always want to make sure to acknowledge the participation of the organizations that really make any research project possible. And the partners here shown are a number of utilities that contributed funding. I mean, certainly microplastics in the grand scheme of things that a utility has to worry about are pretty far down the list at this point in time, between infrastructure in California Water Resources, lead, and a number of other ones. But certainly it's something that they're going to have to be concerned about when the sampling program for the state gets ramped up. And that's kind of where this is going. So just to acknowledge, Golden State Water Company is the utility sponsor for this project. And then the agencies that contributed funding here include those that are both larger and smaller agencies. Some of these are really rather on the small side. And just to underscore, they really appreciate their donation to the project, because without their support and their just acknowledgement that this work has value, none of this research would be possible. And the American Chemistry Council, which has a lot of information about consumer researching, not necessarily with respect to drinking water itself, but about plastics and microplastics generally. And also note that they are a non-monetary contributor to the research to avoid conflict of interest with the results that we might generate. Obviously, this group knows this information pretty well about the California mandate, the definition and the analytical methods and the 4 years of sampling forthcoming. But then even beyond California in the US broadly, there is widespread interest among this topic in both utilities and the general public for the number of media articles that talk about microplastics. And certainly utilities are going to get hit with questions from their consumers as well, even beyond California. But in addition to that, third-party sampling from groups like the Environmental Working Group is ongoing, and they have an interest in publishing their results as well. And for whatever better or worse, they have a slant on their own messaging. And as more of their work gets published with respect to their own drinking water sampling with microplastics, then certainly consumers are going to call their own utilities, not just in California, but across the country. And because of those things, consumer concern about this issue is expected to increase broadly. Research needs for microplastics in drinking water, listing things that are probably most important: occurrence, methods, the treatment efficacy of our processes, potential of some of our processes to shed microplastic particles and whether or not that should be a concern, and then toxicology. I've characterized these as the foundational 5 areas, but it's not just topical, but the execution of the research as well in terms of connecting different researchers, having a conversation about their research and what's important and innovation is taking place in that space, to coordinate efforts and collaborate as well, and then ultimately to communicate findings to the broader community to build institutional knowledge that's important for us. And this project, the Research Foundation really is at the confluence of occurrence and communication and linking those two. And the research is critical because the sampling results for California will be publicly available. As I mentioned, there are already advocacy groups doing similar sampling around the country, and they will publish their results as well. Customers will in turn contact their water suppliers. And really, because of all the other things that utilities have to contend with, heretofore, there's really very little experience with microplastics and associated concerns. And as a result, currently there are no outreach resources for utilities, which is what this project aspires to create. And the 2 major research objectives are to build that institutional knowledge in the industry about microplastics issues of greatest interest to consumers, and then generate the appropriate messaging to address those concerns by way of customer, in response to customer and media inquiries. And we really feel like, in talking to Patsy Tennyson, that this was an unprecedented effort because most of the time, the drinking water industry is reactive, and PFAS is a good example that under the Unregulated Contaminant Monitoring Rule 3, utilities across the country had to sample, results get published, and there's a lot of media attention to PFAS generally. So once it became known that PFAS were in our drinking water supplies, there was a lot of bombardment for utilities about interest in whether or not PFAS were there, and if they were there, what's the risk, what were we doing? And in that sense, as we often are, we're reacting to consumers. In this case, we can see the tide coming with respect to consumer interest once sampling is more broadly implemented and the results are made public. And with that in mind, we have an opportunity perhaps we've never had before, which is to develop the appropriate messaging before it's actually needed. That's our overall intent. Then just quickly about the scope of work, it's relatively straightforward to compile information about what the state of knowledge is for microplastics and the key issues. Then having a planning workshop to develop the key messages that will then be floated in the consumer survey in Class 3. And then based on the results of that survey, we'll have a synthesis workshop to develop what the most appropriate messages were for, I guess in some respects, assuaging consumers, and then those messages to avoid because they elicited negative responses. And then develop the resources based on that synthesis. And then both for a webinar and beyond, try to brief the industry and disseminate the results as widely as possible to equip utilities with tools they need going forward when they get those customer concerns. So that's the overview of that project, and brings me back to the slide I was on before, which is now that we know at least for one sector for drinking water what's going on, not acknowledging people in this group believe that consumer messaging for microplastics is important. What is the point of that messaging? Who is it for? Who is it to? And what are the goals? And I guess with that, I'm gonna quiet myself and open it up for the group discussion so we hopefully can coalesce around at least these two things before we're done with our time today.
Brent, your project sounds fascinating. I hadn't known about your review paper, so I can't wait to get it and read it. And I think that you're covering a lot of what I personally feel that this group can work on. But this is more of an ambient water, and it includes drinking water. So I think that it expands the scope significantly with respect to source control and some other things, and how to explain the risk to humans, public health, and environmental health.
Thank you. And I should note that Scott asked me to participate and lead this group because of the synergy with respect to the project we're doing now. And obviously I'm thinking about consumer messaging, but this project certainly isn't about me at all or what I would like it to be. I mean, this group all comes from a wide variety of backgrounds and interests with respect to the microplastics issue. And so I really want this group to make the messaging what we collectively think that it needs to be and who we think it needs to serve. Any other thoughts?
I feel chatty today, so
no, please.
Yeah. Okay, so what you've already done, I think we need to read it. I think we need to see where you're going with that and the stage that you've set up so that we could adopt it amongst ourselves. I'm in for the long haul in this group. I'm really excited that it's an opportunity for us to talk about this. I'm not a chatty person typically, but the way that we present this information, because we're going to find microplastics everywhere. It's going to be in drinking water. So what does it mean is really important, and how to explain that. So it's not something, it is something that's bad that we find out that, oh yeah, so we have a lot of this stuff here. What do we need to do about it? What are the next steps? I just am tired of social media terrorizing the public. And I think that we need to find a way to stop that.
Yeah, good thoughts. Thank you. And I should clarify, the project is now just getting started. So there's nothing really to report yet. And for just a brief bit about the time frame, our target is to conduct the Task 2 workshop to frame the messaging at the AWWA's annual conference in San Antonio this summer, and then go forward from there with the survey shortly thereafter. So that kind of gives you the rough perspective. Probably about 18 months, give or take, till we have everything coalesced. So there's something to read, if you want to call it like that. But certainly doesn't mean this group can't do something, whatever we think is appropriate in the meantime. Leslie, I see you got your hand up.
Hi, great, thank you. Yeah, I'm excited about this work group. Can you hear me okay?
Yep.
I'm excited about this work group, and I think it's great that it's getting started at this point. And I agree with what's already been said. And it's interesting because, I work with the San Diego County Water Authority, so I always have that water supplier hat on. But of course, there's so much more than that, like air and considering wastewater. But from the water supplier perspective, from the Water Authority, I think a couple of customers at this point is reaching out, and we're a wholesaler, so reaching out to our retail agencies, making sure, they're a customer, making sure that they're aware of what this means. And then obviously to the individual customers, And I don't know how the actual monitoring handbook is going to, what the final handbook is going to look like. But right now there's requirements for communicating to the public through CCRs. So that's an avenue that should be explored. I don't want to get ahead of ourselves though. So I think there's a lot to do at this point still before before reaching out to individual customers. So that's okay. Thank you.
Yeah, and I'll just confirm that any monitoring that is required by the state has to be reported in the CCRs if it's in source waters for drinking water. So the microplastics monitoring that we require will be. So yeah, I think like Brent mentioned, this is a work group that can develop tools for anyone that needs them. And what I see this, one of the products that we could produce is effectively a consumer messaging toolkit. Different messages for different situations, some default language that people could use in their CCRs or frequently asked questions on their websites, those sort of things.
Thanks, Scott. Evelyn, do you have your hand up?
Yes, hi.
Yeah, we can hear you. Thank you.
So I'm curious about a few things. So this information that this work group develops is going to be presented at an AWWA conference in the summer?
No, I should clarify that is part of the Water Research Foundation project that I gave a summary for. So that's completely independent of what we're going to do here. We're just starting down the path with this work group. We can really make it whatever we want it to be. And that's what I'm hoping to try to figure out partly today.
But is that connected? Is the paper that you presented similar? I mean, I just trying to see how it's all tied into AWWA, and is there funding for this work group or for the work that's going on behind consumer education? Because it's just so funny that consumer education is put like way down on the pile of things that need to be supported, where on so many levels it could be one of the most important things that we have to consider, because we don't want to like start open a can of worms and create chaos. We want to kind of tool people to affect behavior change. It's a big conversation. Essentially what you're proposing is kind of creating the narrative from source, to this problem that we're at now. So, and of course the AWWA represents like all the utilities across the country. And I was just reading a water quality report early this morning, and even water information for people with autoimmune disease might be antiquated. It was written like 20 years ago. So, and yet it's in the water utility consumer confidence reports sort of forever, unless there's a big challenge of that. So my point being, whatever is determined as language is going to be duplicated all over the country, as Leslie probably knows very, very well, right?
Yeah, and I guess to answer your question about the funding, the Research Foundation project I just described is completely separate from this group. That does have funding. And Scott, I don't believe this group has funding. This is a volunteer effort to develop whatever we think is necessary for the industry. Is that correct?
Is that what you're saying, to recommend whatever's necessary for the industry as far as language for microplastics?
That could be one of the goals of this work group.
That's a very ambitious goal. I mean, I applaud it, but I just hope that there's funding for that it's not, considered something that's incidental,
So one of the things that we have determined, or one of the things that we've set out that we can do through this subcommittee, is get funding for projects. So through our conversation today and going forward, if we come up with a project proposal, we have some defined goals, then we could submit that to different organizations to get funded.
I just think it's really of course, Scott, that I think this is an important topic, and we can't treat it as an incidental topic, because once the language gets out there, it's just going to be cut and paste. So we sort of have, I guess, an opportunity right now to kind of keep the genie in the bottle before it's released.
Absolutely.
That's what I'm understanding.
Yeah.
Right?
So Brent's totally right that we have the opportunity to be proactive instead of reactive.
Right. Yeah. Thank you for bringing that up. I appreciate that. Thank you.
Does anyone at the group come at this issue from something other than, say, drinking water in terms of their interest, whether that's stormwater or air or anything else? And I guess, Steve, I see your hand up. I'll defer to you. And if you're gonna answer this question, we'll come back to it.
Yeah, I've been sitting here simmering. My name is Steve Jepson. I'm the Executive Director of the Southern California Alliance of Publicly Owned Treatment Works, so the wastewater sector. And so I'm just going to throw out something a little bit different direction, which maybe a little bit of a different perspective. I've read studies that show exponential increase in plastic production globally and nationwide. Huge plastic production facility in Texas has just opened up. So I feel like, now this is a little separate from the public messaging, but as we're learning more about microplastics in our waters and air and stormwater, we're going to be needing to develop ways to control it. And maybe, messaging to consumers to be more responsible with their plastic that eventually degenerates into microplastic might help. But the angle I'm really interested in is legislation to reduce plastics that are more likely to get into our waters, to reduce use of those, and to encourage more polymers that are readily recyclable. For example, the wastewater sector sponsored and passed a bill to make plastic microbeads in facial exfoliating cream illegal. A recent study I saw showed that toothpaste that has the little green flecks in it, those are actually plastic. So people are brushing their teeth with microplastics, and then they're spitting into the sink, and that's going into the sewer and out into the environment. So, once again, not to derail the goal of the group with public messaging, but I'm really interested in more product stewardship. So companies aren't making more and more of these constituents, be it PFAS or plastics, that we have to message and remove from the environment. Let's get it at the source. So I'll be quiet and see what folks have to say to that.
No, thanks, Steve. That was great. I really appreciate that feedback, because that's really what we're trying to do, to see what different angles people may be interested in. So I heard a couple of different things from you that were potentially important. Consumers being responsible about plastic use, and some kind of legislative briefing or advocacy to help facilitate less plastic getting into the environment. Product stewardship, all those are potentially good things that this work group could address.
Yeah, I would agree with that, Brent. And Steve, you said it might be off topic, but I think it actually is on topic.
Agreed.
But I want to echo what Brent said, is that is one of the points that we can get across in this messaging, because it's all connected, right? If we want to make this, if you're interested more about talking about those specific strategies for product stewardship, that would be a different work group. There is a source control work group part of CASA right now that's pretty active. And then there's also the Product Stewardship Council that has their active meetings, but we can definitely draw that information and utilize that in our messaging strategies if we feel appropriate.
Yeah, I work super closely with CASA. They're my big brother for the state. So.
Oh, sorry, I meant CASCA. Actually, CASCA has
CASCA.
Yeah, they have a very active source control work group that's been addressing microplastics.
And of course, CASA does too, and CASA has a legislative branch as well as CASCA, and sometimes we all three work together too. Yeah.
Christy, I think you have your hand up.
Great, thanks, Brent. And hi, everybody. My name is Christy Kehoe, and I support the NOAA Marine Debris Program as our California Regional Coordinator. So really happy to be there today. And for purposes of my work, I tend to focus on coastal and marine environments, but certainly it's all connected. And really excited about the discussion of messaging and specifically what are the target audiences. I saw metrics was brought up of how we evaluate what a successful campaign is. And I think we're asking all really good starting points for strategic planning. But I guess one point that I wanted to jump in on was, I believe someone mentioned up of just like how we get folks to feel like they are part of a solution and how to empower. And that's kind of something we focus at the Marine Degree program, because it's just such a daunting issue. So like, how do we message around people feeling empowered with the information and like either action or, you know, if we target it more in the public or with utilities, like what's the next step? So really happy to go on this journey with you all and happy to help in any way.
Thank you. That's a great perspective in empowering the people, and lots of great ideas. Lots of great ideas positive here. Terry?
Yeah, so I wanted to highlight something that Steve said about communications. That's really, really important. That I think one of the biggest issues with the way that SB 1422 was the issues with it being a legislative mandate is that this is definitely, and I'm just going to say that this is the elephant in the room. The cart came before the horse. And there was so many unanswered questions, so many things that we needed to do. It definitely catapulted the research so that we started down that path to figure out, what the issues are. But to say, all right, DDW, utilities have to monitor in 3 years or 4 years or whatever that is, made it very difficult for everybody, including DDW, to do this. So I think that this part of this communication, this messaging is to also educate the people that are making the laws for us so that they understand where we're at and that we lay the framework for the research that needs to go forward. Where are we at right now? And I think that's why I like that review that you put together, a literature survey. Where are we at now? What is it that we have to do next? And how are we going to do it? So this helps essentially to lay a framework with stakeholders that allows us to be part of this process. And so to develop this path and in a realistic, sensible manner.
Yeah.
And I think that's really important.
Yeah, you're right. I like the cart before the horse analogy, I think is appropriate. But fortunately, they picked the right guy in Scott to steer the cart as it's going forward. So it's an interesting topic. I mean, I regret the fact that consumers are going to be scratching their heads about this, and I hope we can circumvent that. But at the same time, it is a need, and we do need to understand as an industry, what microplastics are out there, and is it something we need to be concerned about? Those things are not known.
And like Christy said, empowering them with the information. What can they do about it?
Yeah, there's a little side conversation going on in the chat here. I was wondering if we maybe could talk about that a little bit.
Yeah, that's great. So Alma, I see that you had a thought. You want to reiterate that verbally, and then we'll follow up?
Sure. Hi, everyone. Can everyone hear me?
Mm-hmm.
Yep.
Hi. Yeah, well, the side conversation really just kind of sprouted from the concept of measuring success. So if we're developing this messaging, I guess one question is not only developing the tools, but making sure that they're effective. So what kind of KPIs how do you measure understanding? Is our messaging getting through to our target audience? How do you measure their understanding? The second point I think in the chat here is about, time, the time scale of change. So, how do you, maybe if you measure that success within 2 weeks, 3 weeks, a couple months, the answer will be no. But if we zoom out a little more, so understanding the time necessary for some of these changes, behavioral, attitude, trust, otherwise, to take place. What are those timeframes that we want to consider? So I'd love to hear folks' thoughts on that.
Okay, so, and I mentioned, because I was vice chair of the Research Foundation Research Committee, to develop the research and communication tools was always a group, and there was always projects funded to work with developing these tools so that this yuck factor was very powerful, and it killed projects throughout the world, not just California, but it was definitely an impediment for moving reuse forward in deserts, in dry climates, and there have been huge projects with stranded assets that are still stranded. So, I mean, multi-million dollar projects. So this is a different type of contaminant. This is a different issue. But I bring up the point of reuse because we start, now this dates me. So back in the late 90s, mid 90s, this work had already started, but that's when we started really hammering in on, and honing in on what do we need to say to communicate with the public, and how, what kind of tools do we need, and how do we measure this? So those same questions came up over and over and over again. And so very comprehensive research tools were developed, including the surveys that I mentioned, that illustrated, and it depended on where it was, because different communities had different perspectives. So if you're in the Northeast and you get tons of rainfall, and you don't even have an irrigation system because you don't need one, drinking wastewater, even if it was indirectly after it's percolated into the ground, was not well accepted, even though UOSA, this plant, had been putting the wastewater discharge into the drinking water reservoir for many years. But once we start talking about the benefits and value of this research, of this monitoring, it builds trust. Once you have a spokesperson like Scott Coffin talking about how much they care about this subject, and that this information, and this is why Scott's been successful, because he's been showing up, he's been, present, and he's been able to talk about this. But we even at that time, Arnold Schwarzenegger was the governor of California, and we thought, well, maybe we could put some commercials together where Arnold Schwarzenegger would talk about reuse, and to try, because the yuck factor was still instilled. It was not well accepted. Again, it's a different type of subject, but the point remains that helping to educate, helping to develop an understanding, and microplastics may not be an issue for public health at the concentrations in drinking water after treatment, but we still need to explain that somehow. And so we don't have to wait 20 years, I don't think. I think an initial survey followed by, the next survey, there is definitely a concern because it's overwhelming. And I think that fear is propagated every time a bad news story shows up. And I think we as this, the stakeholders here, developing these tools to help people find the source of good information would be super helpful to everybody. And then I love the idea of saying, okay, this is what you can do to reduce your plastic consumption, and so forth. It's great.
Thank you. I like the idea about how to measure, and whether or not that's something this group could do for the short term. That's something we should probably discuss, but I love that idea, because rather than just putting resources out there and then kind of, washing your hands and moving on to the next thing, it's important to understand how effective those resources would be. So I'm glad you brought that point up for something to consider going forward.
Thank you.
Being cognizant of time, I know I have a couple of minutes left. Is there anyone else that has something they want to mention in terms of other ideas about the audience for this material, or the goals to try to accomplish? Okay, what I think I'll do going forward is, we're taking notes. Monica's taking some, and I'm taking some as well, and we'll kind of capture the ideas. Scott, maybe you and I and the others can kind of collaborate behind the scenes and see if we compare notes about the main points that were made. Then maybe we'll poll the group again to see over email or an online survey to try to understand what people think is the best path going forward, and maybe take it from there, if that sounds amenable to the group. Steve?
Yeah, I would just say quickly, I guess if I wanted to do some messaging for the public on plastics or microplastics in drinking water, I'd start with a comparison of how much is in bottled water, how much is in your food, how much is in the air, kind of presenting sort of a mass loading perspective.
Yep, thank you. Any other thoughts? Okay, within the couple minutes I have left, then I'm going to just quickly go to a couple other things. Timing and schedule. Scott, what did we decide was the time frame we'd like to have something assembled and sort of ready to go, whatever that ultimately may be?
In terms of our toolkit?
Yeah, well, yeah, or whatever it is we decide is we're going to produce. Sure.
So the thing that's going to happen that's on the agenda is the monitoring for drinking water starting next year. So we've got effectively the next 9 months to come up with some tools for the water systems. So we can work backwards from there. I think it would be useful to start off with a monthly recurring meeting, just so we can build the momentum. And then from there, we can determine if we want to change that meeting frequency.
Okay, that sounds great. So 9 months to sampling, that's when it would presumably start, correct?
The absolute earliest that it could start, yeah.
Okay. And I did hear you say drinking water again. It sounds like that tends to be the way this group is trending. And when you say consumer messaging, in terms of things like air or stormwater or other sources, the one place we do consume microplastics is drinking water. So maybe we'll refine some of the options toward focusing on that, it sounds like, unless I've missed a tenor here.
Can I say something?
Yeah, please.
Go ahead.
Since utilities are going to be required, right, next year in the 2022 water quality report, is that correct, Scott?
Yeah, the consumer confidence report for year 2023 is when they'll have to report it to consumers.
So it's not this year, it's next year?
The monitoring will begin next year, and then it will appear at the end of their CCR.
That would be a very productive, I think, goal for the work group, is to create the language that water utilities can use going forward, because then it puts everybody on the same page. Although I know every utility has their own levers, but maybe there's some way to kind of coalesce the information so that it's not, different from various entities. You know what I mean?
Yeah, getting a unified message, I think, would be really important.
Yeah,
that would be really productive for this
agreed.
work.
And it's certainly a need. And I guess for the benefit of the group, Scott, does the state typically develop some messaging in a new situation like this, when something wholly different is required to be disclosed in the consumer confidence report? Does the state developer give guidance, or is this just something we're forging new ground here if we do it ourselves?
We typically do, yeah. For all drinking water contaminants, we have some information on our website about the health impacts, and most cases, water systems choose to just use that language.
And so what would this group do that would be different than what the state is already planning on doing?
It would effectively expand upon that and act, we will provide the absolute base minimum on our website for the health effects. It's solely based on the science, and it's typically like 1 or 2 sentences.
Okay.
And so this work group could expand on that, and then also measure the impact.
Yeah, in about a year and a half from now, the DEW will be putting together the updated guidance document for the CCR for 2023.
Oh, that's right.
And
yeah.
In that CCR guidance document will be any required language and any recommended language. So for CCR communications, the the water board does provide requirements for specific language that have to be that could have to be included in CCRs. So I imagine Scott's going to get a call in about a year and 8 months from the CCR guidance team asking him for language to include. So
This is a good opportunity now to get ahead of this.
Yeah,
absolutely. And I do want to continue this conversation, but we should regroup with the rest of the group.
Yeah.
So,
and Monica, did you capture everybody who's here so we make sure we can follow up with them down the road?
I got you.
Okay, great. Yeah.
Yeah. Awesome. Thanks, everyone. We'll see you back in the big meeting.
Thanks.
Thanks, Brent. I would like to talk about this again at our next meeting. I think that we have a lot more to talk about.
Okay.
All right. Welcome back to the main room, everyone. I hope your breakout groups were productive. I know ours was really exciting and productive. And so with the remaining 6 minutes that we have, I'd like to hear a cliff notes from the work group leads about what you all discussed in your breakout groups. And I'll hand it over to Shelly Walther.
Thanks, Scott. Yeah, it was fantastic. We went over some basics of what the work group would be working on. And the Cliff Notes version of that would be that we're going to focus what we can feasibly accomplish in the next year. We don't want to reinvent the wheel. We're going to have lots of information sharing through some of the sources you had mentioned, like the Zotero database and the Google Drive that we'll all have access to. And we're going to be meeting quarterly at a minimum, possibly more, depending on what we need to accomplish. And we'll have monthly check-ins for a product. And we do have a survey that I'll put in the chat again. We want feedback from everyone about, what their background is, what they most need to get out of the playbook, and we'll definitely take that. So there's more than a nutshell, sorry.
Wow, that's great. Sounds like a really productive and exciting meeting. Cool. And then I'll hand it over to Brent. Brent, you're on mute.
There we go. Thank you. How about now? Good, thanks. We spent a lot of time talking about the couple points I had mentioned in the previous group session about who's the audience and what the goals are. And a lot of great ideas from different perspectives. We seem to be coalescing around some aspect of drinking water since it's consumer messaging. And the one way we consume microplastics is through, aside from consuming, I guess, in seafood and things like that, around drinking water. And we had a couple of really good ideas about where to go. And we're going to follow up with the group to try to figure out a little bit more refinement, specifically where that needs to be. But one idea that seems to be coalescing is to support and supplement the state's language for CCRs, consumer confidence reports, that utilities are required to issue, I guess now annually, potentially biannually in the future, depending on how the regulation goes. But my understanding is the state generally puts together some generic scientific-based language, a couple of sentences that utilities can draw upon for their CCR. And one potential opportunity this group may have is to expand on that to sort of make the universe of potential good points for utilities to make in their toolkit a little bit larger. And so that's one thing we'll try to explore a little bit.
I'll just add on to that, the idea of harmonizing the messaging so that we're all speaking the same language, and also connecting the concerns about exposure to the greater plastics issue and supporting the strategies to reduce plastic loadings into the environment in general. I think we also decided that we'll be meeting monthly to start off, and we have a goal of producing something by the end of this year to support the drinking water systems that'll be required to do monitoring next year.
Yeah, thanks, Scott.
And so does anyone else have anything else to add? Any questions? Curiosities about the other work groups that they were not able to attend?
Also, I just want to add, yes, the survey may look very similar to the past one that we did in the kickoff meeting, but it's a new survey. So it's focused on the playbook itself. And so if you see a similarity, go ahead and fill it out anyway, because this is specific to the playbook, not the entire group. The other one was for the group. So great point.
All righty, well, I will just end the meeting by thanking you all again for joining. Really exciting discussions today. Look forward to our next quarterly meeting. We'll hear from updates from our working groups, and we'll also have some additional guest speakers join us. So thank you very much, and we'll all be in touch.
Thank you for all for taking the time to come out today, and I'm looking forward to seeing you in the meetings.